Okay, looks like we're down to our last video, Mapcrafter. And this already has a pretty good video online, but we have made some improvements. So if you haven't seen the online video, this will give you just kind of a real generic overview of what you can do with Mapcrafter now. We have some documentation, which if I click this button, I think it's just going to load this. And you can see that it's not very good documentation. So let's just go to the good parts. So you can see that it has some good instructions, or like just the calculators behind the Australian rainfall runoff, the Swiss hazard method, the BOR method, Bureau of Reclamation method, and we've added 2 or 3 more new hazard maps that aren't in the documentation yet. So we're going to fix that in the next coming week or so. Okay. And we also added this peer scour for those of you who are doing solar modeling. We'll talk about that in a minute. But how do you install Mapcrafter? Let's talk about that. So if I come back to the documentation, and you can see right here that we have our installation and setup guidelines. And of course, it's a plugin. It goes directly to QGIS. So we'll do it from here. And then you can see right here that we have installed the Flow2D plugin. So you get access to Mapcrafter from this URL. So what you do is you go to settings and you add, and then you connect to the Flow2D repository. And then search Flow2D in all, and you'll see that Mapcrafter will be right here, but it should say Mapcrafter 2.5.0 or something like that. It should say that right here. So let's take a quick look at it. Mapcrafter. First of all, let's do this. Zoom to layer. Okay. And then we go Mapcrafter. Nope, that's Rasterizer. Nothing new in Rasterizer. It's the same thing it's always been. Good plugin, but nothing new. And then what happens is that you'll point it to this folder, right? Which would just be right here, the 10-hour runs. And then you'll see that if you go to the summary, you'll see that you get some new information. So you see that your units will be displayed here. The engine build that you ran the model with, that's read from summary.out. The grid cell size, the number of elements, the simulation type, which is flood, simulation date, that's the end of the model simulation date, computer runtime, how long it took the computer to run the simulation. So that was right at 54 minutes. So that's hours, minutes, second. And the coordinate system, and then did the simulation run to completion. So I ran this for 24 hours, even though this was just a 6-hour run. It probably could have been finished in 10 hours, but I wanted to compare it to the 24-hour simulation. So I went ahead and ran it for 24 hours instead of 10. And so that's all new. This is new. So I'm going to plot these two, ground elevation, and I'll go ahead and plot maximum depth. And I guess nothing is new, but I'll go ahead and plot that. And then here's derived. So this is kind of new. I mean, I think this one was available in build 23, and then Jim added this one to build 23, 25. This one was available in later build 25, 23, and now in build 25. So what is the difference between the maximum depth, or the maximum velocity, or sorry, this is the maximum of the velocity times depth. This is the maximum depth, and this is the maximum velocity. But why aren't these two the same as this? Because these two are not time synchronized, okay? This one, if you had a ponded water, the velocity would be 0. So that would not be time synchronized to create a maximum. So if you want the maximum of the velocity times the depth, then you need the derived data. Now, this is a file that is printed. These do come from output files that are printed by the Flow2D engine. So this is calculated at runtime. So let me click Create Maps because I want to say something about modified ground elevation. And we'll click OK. And then let's just select both of these. But then what I want to do is I want to zoom in down here. And then I want to just show you the difference in these two files. So you can see that there's significant differences between these two files because, oh, and let's do this. Let's use the profile tool and we'll add these two layers and let's make this one black. And then we'll do a profile across here and you'll see that there is a difference between these two files because the ground elevation is the grid elevation that was interpolated to the grid. But the channel or the modified elevation is the channel elevation that comes from the bank elevation of the cross sections. So you can see here that the cross section is squeezed a little bit closer inside there. Okay. And so that's the difference. Oh, and there are a couple more differences. The modified ground elevation also is modified at the rim elevation of inlets if the rim elevation of your inlet does not match the grid elevation of the grid element that it's connected to. At runtime, the Flow2D engine will reset the elevation to the rim elevation of that inlet, of that node, okay? And along outflow boundaries, if if the node at the boundary looks upstream and sees that its upstream neighbor has a lower elevation, it will reset to 0.1 feet lower than the lowest elevation of its neighbors, of its upstream neighbors. So that way you get the boundary condition, you get that normal depth flow. You can't have normal depth flow if your grid element is looking upstream and seeing a like lower elevation. It can't be calculated. Okay, what's next? Let's go back to Mapcrafter and let's go to the hazard maps. And so you can see we added the Austrian method. I think the Swiss method was already there. We added the UK method. The BOR method was already there, but I think we might have changed the colors. I don't honestly know. And then we added the FEMA method. And in addition to that, so we can do that. And in addition to that, we also added a pier scour map, which I'm not gonna check the pier scour map. I'll show it to you the pier scour map on the documentation. So let's click Create Maps to get the flood hazard map. And you can see here that you can get your FEMA flood hazard. And these are the colors that FEMA is using on some of the mapping that we found online. These are the same colors that they are using. That's why they look kind of goofy. But that's your hazard right here. Okay. Now, that documentation will go online probably within the next week or so. It should actually already be on there, but I just kind of forgot about it. Okay, so we're finished with those guys. Let's take a look at the pier calculation map, because it doesn't make sense to look at it on that project because there wouldn't be any pier scour on that project because everything is covered in concrete. So let's go to the pier scour method. So this is the method that people apply to Flow2D and HEC-RAS when they're modeling, or HEC-RAS 2D when they're modeling solar sites. And HEC-RAS, you're probably applying it to channels. Flow2D, you could apply it to channels if you were doing those channels on 2D. You could probably apply it if you're doing your channels on 1D too. You just have to get your rasters. You'd have to calculate your rasters a little bit differently. And you can see here that you set it up like this, create the pier scour maps, and then, like I said before, if you're using the maximum depth and the maximum velocity and they're not synchronized, you're not really getting the right value. So you want to use, so if you're getting weird results, then go ahead and set it to the time dependent values and process a timdepth.hdf5 at a low time interval. So you get a pier width of 0.5, a K1 at 1, K2 at 1, K3 at 1.1, and armoring. I just put it to 0.6 as just a test, but that one I would say that you would want to be conservative with, I guess. Now, where do these K value coefficients come from? They come from, here's the equation itself. So it's that this is the pier width, this is the depth, and the Froude number, of course, is V over the square root of G times the depth. So that's the Froude number. And here are the correction factors. So the K1 is the shape of the pier, but in solar studies, they're probably mostly round. So I would say 1.0 is your default for that. And the angle of flow attack, since your piers are round, that also becomes 1. I did put a kind of a cute little helper in here that helps you calculate K2. We can do the length times the width and then the angle of flow attack, and then you can compute K2. But it's just a toy. It's not, I wouldn't say don't trust it. Okay, this is the bed condition factor, and this is a much bigger table, but we're not in the middle of a channel. We don't have dunes, anti-dunes, plain bed, anything like that. We're on a floodplain, so I just go with pure water, clear water scour, because we don't have any dunes. And then the K4 is the armoring, is the most complex coefficient because it also is dependent on velocity, and it's also dependent on the velocity of the lift velocity of the particle, and the depth of the water. So what I read, and I don't know if I'm going to state this correctly or not, but what I read in the documentation is that it's not applied correctly. So it's usually not applied correctly, and that's a really difficult thing to apply. So I would just say do a sensitivity study on it, see what it's sensitive to, and see if the values make any sense to you, and test a range of values. Or do you want to go with like a conservative value, or do you want to go with a less conservative value using a more armored bed, kind of depending on what kind of soil you have. So that if you want to do a soil analysis of the, the sites of your solar site, maybe you can get a better K4 value. And as you can see, once you run it, it just adds this little heat map right here. And I applied a style file to the heat map using a style file embedded in the plugin. But I think this is cool because if you open up this style file, I already have it opened. If you open up this style file, you can see how easy it is to create styles for QGIS. And so you can create the style and then export it and then just limit it to only this information. Or you can ask AI to help you create a style file and then you can just test it. And I did a little bit of both of those two things. I asked AI to help me create a style file, and then I fixed it using QGIS, and then I exported it back out to this QML file, which is a style, QGIS style file. Very easy. One of the things that was a little challenging was that these two guys right here they get messed up if you try to put that as the greater symbol. QML can't read that, so it's got to be ampersand GT for greater than and ampersand LT for less than. Then there's some other things like that in here that you'll find as well. So how do you apply a style file? Let's say, for example, that you didn't like that style, or you don't like this style. Let's say you don't like this style. Well, if you double click on this, it brings you to the properties, and if you go to style, you can save this file. And like, we don't want anything. We don't want all this junk here. We just want the symbology. And then let's put that to a, let's see, where do we want to put that? Let's put that to, just for the sake of simplicity, let's just put it right here. And then we're going to call this FEMA style. And we'll click save and OK. And then if we look at that, I think I put that in here. Then you can see it's a little bit more complex because when you export it out of QGIS, you get a bunch of extra junk in it. But like I said, you can give that back to ChatGPT, ask it to clean it up so you don't have all that extra stuff, and just keep it real simple. And then you can change these colors to your liking, so you can do whatever you want with this. This one's a little, I would say QGIS would do a much better job with this than QGIS. or I'm sorry, ChatGPT would do a much better job with this than QGIS. Anyway, so that's style files, and you can set up your own set of style files and apply them using, not only can you just apply them like loading the style like you see right here, but you can also apply them using code. And that's what we do in a plugin. We apply them using code. And I do all of anytime I'm working on code in the plugin, I do it all just with a Python script first, and then I add it to the plugin. So that's how we do plugin development. All right, I'm going to go ahead and stop the video here because this is the end of the last video for Build 25 updates.